For this example, we have one that's a little slightly different, so you want to pay close attention to this. Again, we're doing the same process, describing the table in words, equations, and a graph. This time, though, you'll notice that the x values aren't increasing by 1. And we had talked about how that would come up, so this is how we'll handle that. When we describe it in words, we still have to know how much it's increasing by. We see that it's increasing by 17 each time in our independent variable for x. We also see that y is decreasing by 1. So we'd say that it's adding a negative 1 every time, or we're subtracting 1. Thinking of it as addition. Adding a negative 1, it's decreasing by 1. So when we use words to describe that, we would say that as the miles traveled increase by 17, the result of that is that the gallons of gas decrease by 1. Because it decreases there, now we know that our graph is going to be a decreasing graph. So we want to keep that in mind, and we'll mark that as well. It's going to be a decreasing graph because as we go this way, those values decrease. Now let's write that equation. We know that the equation always starts with y is equal to mx plus b, and we have to fill in for the m value, which we now call the slope, and b. To find m, we want to know, well, what is the ratio between that independent variable changing and the dependent variable? We put y over x. How much is that dependent variable changing in comparison to x? And that looks like a negative 1 over 17. Previously, we just divided that to get a nice slope. This time, it's a fraction. We're just going to leave it as a fraction. So then, when we write that in our equation, we have y is equal to a negative 1/17 x plus that b value. Again, we're already given y when x is 0, so we don't have to find it. That b value is 11 2/10 because we already know how many gallons of gas there were when 0 miles were traveled. That's our starting spot. That's our b value. So now let's plug in one of those ordered pairs to see if we did it correctly. We look at that negative 1/17, and a number to multiply that would work the best, the easiest, is going to be this 17. Because 1/17 of 17 gives us a nice whole number. So let's use that ordered pair first. The ordered pair altogether is 17 and 10 2/10. So we're going to plug in that 10 2/10 for y and set that equal to negative 1/17 multiplied by 17 plus 11 2/10. When we simplify that, we can multiply that fraction by just saying negative 1/17 multiplied by 17 over 1 and multiply straight across. Well, 17 times a negative 1 is a negative 17, and 17 times 1 is 17. When we simplify that, we just get negative 1. So that's that simplified. So now we can say that we have 10 2/10 is equal to negative 1 plus 11 2/10. Now when we simplify this, we get negative 1 plus 11 2/10 is like saying 11 2/10 minus 1, which is 10 2/10. So we have a true sentence telling us that our equation with our m value and our b value is correct. Again, because it was a decreasing dependent variable, as our independent variable increased, our slope turned out to be negative. Because it's decreasing, our graph is also going to show that it is decreasing. So let's give that a try in graphing. Let's name our variables, or name our axes. We have x as our miles traveled. And we have Y as the gallons of gas left. So let's think of a scale to count by. When we look at X, it's no longer counting by 1. And we're not going to use 17 because that's not the best number to count by. It's not the easiest, nor is it the funnest. So we're going to pick a number close to 17 that's still going to get us all the way up as high as we need to. 17 is close to 15 and it's also close to 20. We can use either one of those. Let's try it with 15. So if we put 15 here, this is 30, 45, 60, 75, 90. And that should be plenty far. We could have even spread those out a little bit, but we'll be okay. Now when we look at our dependent variable, that gallons of gas, Y, it's a little bit lower. And we notice that it's decreasing. So we're probably we could count by ones there because counting all the way up to 11 isn't super high. So let's do that. We have to get all the way up to 11. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You want all of the spacing in between to be the exact same, which is why you use your graph paper. Those blue lines are there for you. Each one of these hash marks should be one of those blue lines. And let's label them. Okay, now we can fill in those points. We know that right away in the beginning, 0 miles traveled, we're at 11 and 2/10. That's going to be just above 11. After we travel 17 miles, we're at 10 and 2/10. 17 is just going to be a little bit after 15. And then we're at 10 and 2/10. Just above. That one could maybe even be moved a little bit to the left. Then after 34 miles driving, we're at 9 and 2/10. So go over to 34 and up to 9 and 2/10. You'll also notice that those grid lines will help you put the points in the correct spot. And then at 51, we're at 8 and 2/10. So we'll go over to 51 and up to 8 and 2/10. Again, it should create a straight line because we're working with linear functions. And because you'll continue to drive miles, that line should have an arrow on it because it's going to continue all the way down. Because none of our points are way off the line, we know that our line is accurate. The more points we have, the more accurate that line is going to be. And again, the line is decreasing because as the independent variable increased, the dependent variable decreased as a result of that. So overall, it's going to be a decreasing slope, which you see, kind of like going down a hill, a decreasing slope.